Now here is another problem dealing with the extrema of a quadratic function. First, let's find the vertex of our parabola. We know that this parabola is facing up because the leading coefficient is positive. And the vertex always happens where x is equal to negative b over 2a. In this case, we would get positive 2 for x. Now let's talk about cases. If a is greater or equal to 2, the minimum value would be equal to f of a, and the maximum value would be equal to f of a plus 2, because in this case, all we're focusing on is the right side of the parabola, the right side to x equals 2, which is always increasing. Now, our next case is when a plus 2, the highest end of our interval, is less or equal to our line of symmetry. In this case, we can further simplify and say that this is when a is less than or equal to 0. In this case, the minimum value is equal to f of a plus 2, and the maximum value is equal to f of a. This is because, in this case, the function is always decreasing. The higher the input gets, the lower the output gets. Now we have a third case. This is if a plus 1 is equal to 2. We got this a plus 1 from finding the number right in the middle of the interval. This is saying if the interval is symmetrical about x is equal to 2, then it means the minimum value must be the vertex, because this interval contains a vertex. And the maximum value is just f of a and f of a plus 2, because they would be equal. Also, in this case, a would be equal to 1. Now we have another case. This is if a plus 1 is in between 1 and 2. Now, what does this mean? How did we get this? Here we're still talking about the interval containing the vertex. But now we're saying the interval is slightly shifted to the left. So now the part of f of x we're dealing with is only this part that I'm highlighting in black. In this case, the minimum value would still be the vertex, f of 2. And the maximum value will be equal to f of a. Now, what about our last case? This is if a plus 1 is slightly shifted to the right side of x equals 2. So now our interval is kind of here. We are dealing with this part of the function f of x. This case, the minimum value is still equal to the vertex, and the maximum value is equal to f of a plus 2. And in cases 4 and 5, we can further simplify to get a is between 0 and 1. And in case 5, a is between 1 and 2. Now let's further simplify. F of a is equal to a squared plus 4a plus 1. F of a plus 2 is equal to a plus 2 squared minus 4 times a plus 2 plus 1. This is equal to a squared plus 4a plus 4 minus 4a minus 8 plus 1. This is equal to a squared minus 3. Now, everywhere we see an f of a plus 2, that's equal to a squared minus 3. And everywhere we see an f of a, that's equal to a squared plus 4a plus 1. Oh, I'm sorry, it's supposed to be minus 4a. Now, what about the vertex? The vertex is when x is equal to 2, so we input that into our function. That is when we have 4 minus 8 plus 1, which is equal to negative 3. And f of 2 is the vertex. So these are all negative 3's. When we have our specific third case, we know a is definitely equal to 1. So in this case, the maximum value, we just substitute 1 for a, is equal to -2. And there we have it. We have all of the extrema for f of x on the interval from a to a plus 2 in all 5 possible cases.